Good afternoon, everyone. My name is Pavle Ljubo. I'm a PhD student and teaching assistant at the Faculty of Mechanical Engineering in Belgrade. And today I will present you a paper by the group of LGO on this slide. We are all from the Department of General Machine Design. The title of paper is Influence of Lubricant Contamination on Ball Bearing Rating Life. Here is the short overview. I will first introduce to a problem, then I will mention two very important factors, and I will give you a numerical example. I will discuss about that numerical example, and for the end I will just point out some main conclusions. So this slide is very rolling bearing is very important. Service life is a number of revolutions of operation time until failure. Failure of a rolling bearing can be caused by damage of some parts like outer ring, inner ring, rolling element, or the cage, and that damage is caused mostly due to material on inappropriate lubrication, but also the contamination of the oil or some other lubricant can affect damage of some of these parts. According to ISO standard, the structure can be limited by subsurface and surface. The standard for the calculation of dynamic load rating and rating life of rolling bearings take into account the influence of surface intensity by factor. On the other side, the basic formula for rating life takes into account just subsurface. We have factor. That factor depends on the lubrication, characteristic of lubrication, contamination of that lubrication, and the material characteristics, more precisely fatigue load limit of that material. And that factor is factor A ISO. Here is the standard equation for calculation standard rating life for ball bearing of ball rolling bearing. The basic equation doesn't consider that factor A. So just consider factor A1, which take into account reliability. When reliability of the bearing is 90% or more, that parameter is equal to 1. Also, we can see the equation for calculation that A is a factor. And when we consider that factor, we have to divide all parameters two groups. The groups the bearing, which means the characteristic of bearing, characteristic of material, geometry, etc., and operational conditions, which consider oil viscosity, operational temperature, rotational speed, contamination of lubricant, and operational load. And here in this equation, these parameters A is related to viscosity, relative viscosity ratio. That relative viscosity ratio is that kappa, and it depends on the each diameter and oil viscosity, operation temperature, and rotational speed. That Cu is the fatigue load limit. P is operational load, and all these exponential values are obtained by experiment. Here's the very important factor for calculating factor I ISO. That is factor of contamination, and that factor of contamination takes into account the contamination of oil or another lubricant. We have five levels of contamination: high clean lubricant, normal cleanness, slight to typical contamination, severe contamination, and very severe contamination. And this factor can be given as a table value. This diagram here on the slide is based on that table values, or that factor can be given as equation where depends on pitch diameter and some other parameters. That parameter A cannot be higher than 1. That is limit condition for factor of contamination because he is in the range theoretically from 0 to 1. And here we can see diagrams for based on previous equation. And this red line is limit line, which limit that factor due to parameter A, which is lower than 1. We can see that by increasing the pitch diameter, the lubricant contamination factor increase, and by increasing the relative viscosity ratio, also that increase, and by increasing contamination of the oil, the factor of lubricant contamination decreases. And these two diagrams is for high cleanliness of lubricant and normal cleanliness of lubricant. Also, here is the same diagram just for a slight typical contamination of lubricant and severe contamination of lubricant. And here is the last one, the diagram for very severe contamination of lubricant. We can see that for smaller bearings, which pitch diameter is lower than 65, the contamination factor is equal to 0. That means that the smaller bearings cannot operate under the conditions when the lubricant is very contaminated. Here is the numerical example. We analyzed the contact ball bearing 6306. And here you can see the geometry and the operational values for that. Operational values by this dynamic load rating and fatigue load limit. We consider 3 cases. First case is when is operational load very light, just 10% of dynamic load rating. The second case is when operational load is new, the half of the C, and the last case is when operational load equal to C. Here we can see on the right side the diagram of lubricant contamination factor versus viscosity ratio and oil contamination level. And on this horizontal line for values of kappa higher than 1.5 and for high cleanness of lubricant, tell us that the maximum of the PC factor value is 0.82. And here is the 3 most important diagrams in this presentation. Here is the dependence of factor A ISO on the viscosity ratio and the, of course, cleanness of lubricant for 3 cases that we consider. And this red line is for a very severe contamination. I already mentioned that for small bearings, the factor is equal to 0 for very severe contamination. But in real, that bearing will work for some short period. So that is the limitation when is that factor equals to 0.1. In order to be quick, I will just read some main results from these previous diagrams. That modification factor of systems approach increases with an increase in the viscosity ratio and lubricant cleanliness, and with decrease in the load. The minimum value is 0.1, as I already said, but the maximum value here on that first diagram that is not shown because for clearance, that's not shown because it will go up as the. I'm sorry. The maximum value of factor ISO is 50, which means that for very clean lubricant and for other conditions, the exact rating life of bearing can be 50 times bigger than basic rating life. And when is the value of modification factor approach less than 1 rating life, shorter the rating life or determined by the basic rating life formula. And for the end, some conclusions, the level of contamination can have a great impact of rating life of the bearing. Also, the factor that contamination of oil is taken into account by the A ISO factor, and by using mathematical model, we obtain much more precise values of the contamination factor than the table values. And under certain circumstances, high cleanness, relative viscosity greater than 2.5, or working load, the rating life bearing can be up to 50 times greater than the basic rating life. In some cases, rating life can be shorter than basic rating life, but which is also very useful information for us as constructors. That's all. Thank you for your attention.